Hi guys, we have a jam question here that says given P to be a 2 by 2 matrix with elements 2, 1, minus 3 and 0, I is a unit matrix also 2 by 2. Should evaluate P squared plus 2P plus 4I. So how do we go about this? The first thing is to write our terms and we're going to express them. We know P in two places is P squared is P in two places and we just write it out. 2P is 2 times P, that is multiplying matrix P by a scalar factor of 2, which is actually a very simple multiplication, and 4I will be multiplying matrix I by a scalar factor of 4, which is also simple. An identity matrix or unit matrix is a matrix that has the leading diagonal with having unit element, that is 1. So how do we go about multiplying a matrix that by another matrix in the case of P times P? Now the rule is simple. When you have a 2 by 2 matrix, as in this case, multiplied by another 2 by 2 matrix, your result is also going to be a 2 by 2 matrix, and we denote the elements with A11, A12, A21, and A22. Now, what do these subscripts represent? 1, 1 means that the entry is in the first row and the first column. 1, 2, and the second instance means that the entry is in the first row and the second column. 2, 1 in the third case represent that the matrix is in the second row and the first column, and 2, 2 represent that the matrix is located in the second row and the second column. So the first number is representing the row where the matrix is located, and the second number represents the column where the matrix is located. So commit this to memory, but knowing these denotations can also help us when we are multiplying one matrix by another matrix. For example, if I want to find the first entry of this my unknown product matrix here, I'm going to multiply the first row, that's A11. I'm going to multiply the first row of matrix A by the first column of matrix B. And what does that give me? That will be 2 times 2, which is 4, and 1 times minus 3, which is minus 3. So I'll add my results together and I'm going to get 4 plus minus 3. For instance, in the second case, we have A12. Now, the first number represents the row, second number represents the column. Don't forget that. So that implies that I will multiply the first row of matrix A by the second column of matrix B. So that would be 2 times 1, which is 2, and I'll add it to 1 times 0, which is 0. So that will give me 2 plus 0. In the third case, I'm going to multiply, remember 2, 1 is second row and by first column. I'll multiply the second row of matrix A by the first column of matrix B. So that will be what? Minus 3 times 2, which is minus 6, plus 0 times 3, which is still 0. And in the last case, which is 2, 2, second row, second column, it means I'm going to multiply my second row of matrix A by the second column of matrix B. That is minus 3 times 1, which is minus 3, and I'll add it to 0 times 0, which is 0, and I'm going to have minus 3 plus 0. So in the other cases, which is the 2P, 2 times P, multiplying the matrix by a scalar just means the number outside to multiply the number inside. 2 times 2 gives us 4, 2 times 1 gives us 2, 2 times minus 3 gives us minus 6, 2 times 0 gives us 0. In the third case, which we have the identity matrix, 4 times 1, 4, 4 times 0, 0, 4 times 0, 0, and 4 times 1, 4. As simple as that. So when we simplify what is in the first term, we have 1, 2, minus 6, and minus 3. Remember in the first case, plus opens the bracket, so we have 4 minus 3, which gives us 1. So we have something. I will just bring these other matrices down. So, and I will simplify this. Now how do we add? Adding matrices just means you add all your A11s, add all your A12s, add all the corresponding entries. So 1 plus 4 plus 4 gives us 9. 2 plus 2 plus 0 gives us 4. Minus 6 plus minus 6 is the same thing as minus 6 minus 6, which is minus 12, plus 0, which is still minus 12. And minus 3 plus 0 is minus 3. Minus 3 plus 4 is greater and is positive, so we are going to have 1. Thank you for watching.